Hello everyone, welcome back to Math with Allison. Today we're going to be continuing our series on limits. If you haven't already, make sure to check out some of my past videos. Click that link in the corner, it'll get you there. Otherwise, we're talking about slanted asymptotes today. So let's just go ahead and dive into it. Question of the day, what is a slanted asymptote? And we've worked with vertical, we've worked with horizontal, those were up and down, left and right. Slanted is going to kind of be what it says it is, it's just slanted. So here we have an example. The red function is the f of x, that's our function that we're working with, and this blue function is a slanted asymptote. Typically it's a linear function. So notice that as our x value approaches infinity, our function gets really close to our asymptote but doesn't quite hit it. It does hit it right here. It doesn't really matter what happens in between. What we care about is that end behavior. So as x approaches negative infinity, that function is going to get really close to the slanted asymptote, but not actually hit it. So how do we find a slanted asymptote? First, we're going to start out with the algebraic way. Calculus is built on algebra, so make sure we have that in our back pocket. We are going to have to do long division, unfortunately. I'm going to go over this with us in case we don't remember. But I have x minus 2 on the outside here, and then our function on the numerator on the inside. So we need a number right here that multiplies by x to give us 2x squared. So I'm going to go ahead and multiply by 2x. When I do that, I get 2x squared, but don't forget, we also have to multiply it by the second term. So I get minus 4x. We are not adding this, we are actually subtracting it because we want that first term to zero out. 2x squared minus 2x squared is equal to 0. But we have to distribute that to this second term as well, so that becomes a positive. So now I have 4x minus x, so I get plus 3x. Now I'm going to go ahead and drop down the next term. I'm going to drop down that minus 3. So now I need another value. It's going to multiply by x in order to get 3x. So I already have an x, so I'm just going to multiply by 3. 3 times x is equal to 3x. Don't forget to multiply it by the next term. So I get 3 times negative 2 is equal to negative 6. And now we're going to go ahead and subtract the whole thing. I'm going to make sure to distribute it to each term. So I get minus 3x, which gives us a 0. But now that 6 becomes plus. Negative 3 plus 6 is equal to 3. And so this is just equal to 3, right? That's our remainder. We can't multiply x into it. And so now how I would write this is I would have 2x plus 3 plus 3 over the denominator. So x minus 2. This is where we find the slanted asymptote. It is whatever we have right here. And so the slanted asymptote of f of x, we write it as L of x is equal to 2x plus 3. So how do we do this with calculus? There's not a calculus way to find the slanted asymptotes, but we can prove that it is a slanted asymptote. So let's go ahead and look at the definition. We have the limit as x approaches infinity of f of x, the original function, minus the L of x that we get, the slanted asymptote. This needs to equal 0. Or the opposite, as x approaches negative infinity, is equal to 0. So that means the space between the function and the slanted asymptote, they get so close together that there's a distance of 0 between them. So let's go ahead and work this out. We have the same function as before. First, let's go ahead and just compute f of x minus L of x. So remember, when we have a fraction minus a whole number, we need to create a common denominator. So I'm going to multiply this one by x minus 2 over x minus 2. I'm going to go ahead and multiply out that numerator. I'm going to go ahead and combine like terms. Okay, so now I'm going to combine the two fractions. So remember, when we combine fractions, the denominator stays the same. And then I'm going to go ahead and take my first numerator, and I'm going to subtract the second one. Do not forget to distribute that minus to every single term in there, also the 6. So when I do that, I get minus 2x squared plus x plus 6. And notice here that we get some terms canceling. The 2x squared minus 2x squared cancel, negative x plus x cancel, and then negative 3 plus 6 is equal to 3. So now as a fraction, I get 3 over x minus 2. So now I have it as simplified as I want it to be. And now my second step, I'm gonna go ahead and compute the limits. So I'm gonna plug those in real quick. So remember, when our denominator is getting really, really big, going to infinity or negative infinity, our limit goes to 0. So both of these values goes to 0. If we don't quite remember that, make sure to check out this video. I have what does 1 over x do? So this tells us that our L of x, the slanted asymptote, which was 2x plus 3, really is a slanted asymptote. Now we proved it with calculus. Let's go ahead and view another example. This one's a bit different and we don't have to do long division. Instead, we can just go ahead and rewrite this as x squared over x plus 9 over x. Simplifying this down, I get x squared divided by x is just x plus 9 over x. The fraction part we ignore, but whatever's before the fraction is our slanted asymptote. So I'm going to write that L of x equals x. Let's go ahead and use calculus to prove this is a slanted asymptote. I'm going to take f of x and subtract that value. If I want to combine two fractions together, I need to create a common denominator. So I'm going to multiply this by x over x. Now that they have a common denominator, I'm going to combine them into 1. And now I get some terms that cancel. So my x squareds cancel, and I'm left with just 9 over x. Our second step now is to plug those into limits. I'm going to go ahead and write them out. So it doesn't matter which infinity we're approaching, positive or negative, these are both going to go to 0. Which shows us that this is indeed our slanted asymptote. Let me write that out. So that's all I have for us today on slanted asymptote. I hope you guys enjoyed the video. If you did, please leave a thumbs up and comment other videos, topics, and problems you'd like to see done. Thank you so much for watching.